All right, everybody, this is going to be part 2 of solving equations. So what we're going to look at is we did last in part 1, we did 1, 3, 5, 7, and then I went over it and I did number 9. Okay? So if you didn't get that or you haven't seen that yet and you don't understand those, I would go back and watch those, because here we're going to get into special cases. And like I said, if there's stuff you don't know that you don't understand, hey, get a hold of me. Let me know. Okay, I'll help. I'll do whatever I need for you. These are weird times right now, so get a hold of me. Let me know. If it's during the live session, I'll rework these. I'll do whatever you need me to do. Just, you got to let me know what you're struggling with, okay? All right, so we're going to go through special cases. Let's look at special cases, okay? So we have nothing too crazy here. The math, in fact, looks to me, when I first look at this, right off the bat, it doesn't look like a special case to me, but I'm sure since it says special cases, something crazy is going to come up. We're going to look at proportions, which is 2 fractions. Oh my goodness, I'm so nervous. You'll be all right. And then we're going to look at literal equations. Literal equations means there are literally no answer that we're going to get as far as like x equals 9 or something like that. You're going to get other letters involved. Okay? There's going to be other letters involved in your answer. We're just getting stuff by itself. All right? So let's go into special cases. Let's look at this first special case on number 11. First thing I'm going to look at, we talked about, let's distribute. So 5 times 1 is 5, minus 5 times c is 5c, plus 8c equals, I get 1 plus 3c. Okay. Looks good so far. I separated into 2 sides, a left side and a right side, and I check sides. Is there anything on the left side I need to do? And nothing I can do. 1 plus 3c is not 4c. Remember, these are not like terms. You can't just like add any crazy stuff together. Okay. 5 minus 5c plus 8c. 8c and 5c are the same. So since I wasn't doing anything on the left, what I can do is I can combine those like terms. 8c minus 5c is a positive 3c. Don't get confused. I'm not doing the opposite yet. When do I start doing the opposite? I start doing the opposite when they are on opposite sides of each other. If they're on the same side, just do normal math. Don't overthink this. A lot of times kids will overthink stuff. They'll make it harder than what it is. Okay? Mom and dad haven't seen this forever, so they don't remember either. It's okay. But just don't overthink it. Do what it says on that side. When they're on opposite sides, do opposites. What do I mean by opposites? Inverse operations. If you see adding, do subtracting. But I didn't need to do that here because these are doing what it says. A positive 8 minus 5 is a positive 3. Okay? All right. Now, you can get your variables together. So if I see plus 3c, let's get them on the left. We're going to subtract 3c. I'm going to subtract 3c. So I'm going to get 3 minus 3 is 0. My c's are gone. Equals 5. 3 minus 3 is 0. My c's are 5. Or c's are gone. Excuse me. All right. I have no more variables. I have no more variables. They all disappeared. They all canceled out. So when you have no more variables and they're all gone, see how they disappeared? 3 minus 3 is 0. They're all gone. 3 minus 3, they're all gone. I got no variables left. And when you got no variables left, does 1 equal 5? There's nothing I can do here. In fact, most people, when they get here, they'll be confused, as they should be. Because there's nothing left to do here, and 1 does not equal 5. So this is a special case because, hey, Mr. Thrasher, all my variables disappeared. Yup. And I got something like 1 equals 5, and that doesn't work. Yup. So if it doesn't work, like if all your variables are gone and there's nothing left to solve and you can't get an answer, then what we call that is we call that no solution. Okay? what does a solution mean? A solution means when you guys are able to get a value where these two things will intersect. If we were to have you guys graph these, we're trying to find where these two sides cross. Well, these two things never cross. Sometimes things don't cross. When you guys first started Algebra 1, they probably had you graph lines. And you guys tried to find where those lines crossed. Okay? Sometimes things don't cross. These never crossed. So there's no solution to it. Okay? So if you're in the city, where does Craig Road cross with Flamingo Road? It doesn't. If you know anything about how the city works, those two roads don't cross. So if I ask you to find where they cross, you would be like, well, Mr. Thrasher, they don't cross. And that would be a no solution where things don't cross. That may happen. Very rare. That doesn't mean that if you get stuck that you're going to get no solution. The only time that really happens is if your variables all disappear. Okay? Sometimes kids get to problems that look like this and instantly think it's no solution because you got two fractions and they hate fractions and they're already... No. This is a special case. Why is it called special? Because it's rare. It doesn't happen all the time. Okay? It's special like your birthday. Doesn't happen all the time. Okay? So it'll happen every now and then. Okay, let's talk about solving a proportion. So proportions are fractions. There's nothing I can really do on either side of the fractions. There's no distribution. There's no anything other than that. So when you have a proportion and when you have a fraction, what do I usually tell people when they get fractions in their equations that they're trying to solve? Is get rid of the fractions. Fractions are confusing. So if they're confusing, let's get rid of them. Okay? So how do we get rid of something? I need you to remember, I made this post-it from part 1, that a fraction means division. Okay? So its inverse, what is the opposite of division? The opposite of division, or the inverse, the big fancy math word we use, the inverse operation, the opposite step of division is multiplication. Okay, so how do we get rid of division? We can use multiplication. That will undo it. So what do I see here? I see a fraction. So the opposite of dividing by 3 is I can multiply both sides by 3. Multiplying and dividing, and I should draw my line down the center like I told you. I should follow what I say. If I'm dividing by 3, the opposite of dividing is multiplying. You can multiply the 3 and the 5 together if you want. 5 times 3 is 15 and then divide it. But understand, opposites cancel. So division and multiplication will cancel. We're multiplying both sides by 3. 3 times 2 is 6. And I get 6 over x plus 4. Look, after all that hard work, one of your fractions is gone. But we still have another fraction. It's okay. If it worked to get rid of the first fraction, do the same step and multiply both sides to get rid of what's on the bottom of that second fraction. So we want to get rid of, remember what makes something a fraction is that it has a bottom or it has a denominator. So since x plus 4 was in the denominator, we're going to multiply both sides by x plus 4. Opposites will eliminate or be gone or canceled or however you want to phrase it. I have x plus 4 times 5. Now you have two things, a group of things if you will, being multiplied by 5. So 5 times 4 distribute is 20. It's a positive 20. And 5 times x is 5x. So we get down to 5x plus 20 is equal to 6. Look, you have no fractions. Yay! I have no fractions. No fractions. If you don't like dealing with fractions in an equation, get rid of them. Get rid of them. Now it turns out to be an old school problem we're just doing in part 1. Separating two sides. Subtract 20 from both sides. I'm running out of room here because I wrote too big. 5x equals 6 minus 20 is negative 14. I'll bring it up here. 5x equals negative 14. How am I going to get rid of that 5? I'm going to divide both sides by 5. Does 5 go into 14 nicely? Good answer. It does not. So your answer is going to be negative 14 over 5. Okay? Proportions. Some teachers you may already know this. Like there may be some of you that's chirping at the screen to me. Like, Asher, my other teacher told me to cross multiply. Okay, if that's what you could remember. I just don't like using the phrase cross multiplying because some people get confused with what that means, and I understand why you get confused. When I say cross multiplying, do you think across or do you think cross? Like which direction? So I just try to emphasize conceptually to get rid of division by using multiplication. Okay, do you guys notice how 3 times 2 is 6? Do you notice how the 3 didn't change the x plus 4 on the bottom? Okay. If you don't like fractions in your problem, get rid of your fractions. All right, last 3 in this section, and then we'll be done. Literal equations. Literal equations. They have more than one variable. Is the simplest way I can think to say it. Okay, so literal equations have more than one variable. So what we're going to do is we're going to get the variable that they asked for by itself. Okay, a variable is just a symbol that represents a number. It can be a letter, it can be a symbol, it can be a picture, it can be an emoji, it can be whatever. It's just something that represents a number. Okay, so in your directions it says solve each equation or formula for the specified variable. Okay, so in 15, it wants us to solve for pi. So what does that mean when it says for pi? What that means is get pi by itself. So move stuff away from pi. So what your focus is going to be wherever pi is at. My focus is going to be on the right side because that's where the pi value is. So what you're going to do is you're going to move stuff. You're just going to place it on the other side. It's just like moving furniture, just like moving the desk. You're going to pick it up, you're going to move it. It's going to be on the other side. You're getting it away from a certain side of the room. Ooh, I don't like this couch on the right side of the room. I'm putting it on the left side of the room. I don't like this 2 and this r with pi, so I'm going to move them away. So we are going to move the 2 and the r. So we are going to move the 2 and the r. Okay? How do you move stuff? You do inverse operations, what we just talked about in part 1. If you see adding, move it by subtracting. If you see subtracting, move it by adding. If you see multiplying, move it by dividing. And if you see dividing, move it by multiplying. How do you know when you see division? When you see a fraction, because what does a fraction mean? A fraction means division. Okay? All right, all of these are side by side. I don't see any subtraction signs, so I'm not going to use adding. I don't see any adding signs, so I'm not going to use subtraction. I don't see any division, so I'm not going to use multiplication. But what I do see is side by side. This means multiplying. How do we get rid of multiplying? We divide. So we're going to divide both sides by, let's divide both sides by 2, because that's the first thing that I see. C divided by 2. Do you know what C divided by 2 is? Nope, either do I. So if I don't know what something is, I leave it as a fraction. There you go. But the answer looks weird. It's okay. There's a lot of things in life that look weird. Just deal with it. Just embrace it. Things look different. That's what makes us special, is our differences. These two things are side by side. That also means multiplication. So let's get rid of that. Let's divide out the r. Let's divide out the r. So the 2's cancel, the r's cancel. So I'm going to get pi equals. Some kids will get lost here because they don't know what, they already see a fraction and then we're dividing by the r. R also means it's getting divided there. So if something's getting divided, we can show it as part of a fraction because a fraction means division. Kids, you already got a fraction. You got C on the top and you got 2 on the bottom. Is R getting divided? Yep. So put it also on the bottom. Can you see that? Probably not because of my terrible writing and use of space there. Okay. So you're going to get C over 2R is equal to pi. You've now solved for pi. You've gotten it by itself. That's all that means. Get it by itself. That's it. Get it by itself. Okay, let's look at 17. So we want to get B. So this says solve for B. It tells us right here, solve for B. So what does that mean? That means get B by itself. Okay, I know you haven't watched many videos by me and you haven't worked too much with me, but I write in capital letters probably all the time. Most of the time. 99.2% of the time. Okay, so let's get B by itself. Here's B. There it is. So this is what it said to do. Solve for B. I see B right here. Oh my goodness, I got to get it by itself. So ask yourself, what am I moving? I'm moving that A and C because I want my answer to look like this. B equals stuff. Moved around stuff. Okay, so some of you are going to look at this and already know how to get rid of it because A and B are being what together? They're being added together. How do we get rid of adding? We subtract. But Thrasher, I see a fraction. Yep, and you already know what a fraction means. A fraction means division. So, what's the opposite of dividing? To multiply. So, do you want to do that right now? We can. I always emphasize getting rid of fractions. So, let's multiply both sides by C and just get rid of the fraction because it will cancel out the denominator. I'll get A plus B equals 5 times C. And 5 times C is just 5C. There's one last step. I want you to get to the point where you can see it in your brain. We're going to get rid of adding because it said get B by itself. B is almost by itself. You moved away C. Now let's move away A. A is being added to B, so let's subtract it. Let's subtract it. Inverse operations, they'll be gone. You know what this is. Now, you're going to overthink it, some of you. Some of you won't. It's okay. Like I said, it's the biggest problem we get into in algebra and stuff is we overthink stuff. Do you know what 5C minus A is? Either do I. So write down 5C minus A. Those aren't like terms. I'm going to move this post-it. We're going to do 19, and then we're going to be out. Check what it says. It says solve for V. Great. V is right here. I see a couple things going on. V and W are being added. So already in my answer, I know I'm going to subtract W. Ooh, I see a fraction. A fraction. Ooh, what does a fraction mean? A fraction means division. How do we get rid of division? We multiply. So do those steps. See me dividing by 2 here, and I know I got a 1 out front. We'll show you what to do with that here in a second. So let's multiply both sides by 2 right now. So I'm going to get 14W equals, you can keep the 1 here if you would like, and you can keep the W plus V in parentheses. Make sure you say that right. Dividing by 2 and timesing by 2 are inverse operations of each other. Now, this 1 is by the parentheses. Do you want to distribute it in? You can. So we get 14W, but it's kind of silly. You don't need to distribute 1 in. If it was a different number, you'd want to, but we don't need to. That's one way to do it. Another way to do it is some teachers and some kids understand reciprocals on both sides. If not, it's whatever. Finding a process that works for you, that's the main thing. So if you're like, Thrasher, I already know how to use reciprocals, then do that. I want to get V by itself. So if I'm adding 1W to 1V, then let's subtract 1W. Remember, when you subtract, I got 1v over here. Are these like terms? Do you know what 14w minus 1w is? Yeah, it's 13w. Those are like terms. They both have w's. So that's a 13w. Your last step, get v by itself, divide by 1. Do I need to do that? No, it's a silly step because when you divide by 1, you all know when you divide by 1, it doesn't change anything. So v is equal to 13w. Okay? All right. All my best to you. If that makes sense, good. If it doesn't make sense, get a hold of me. Let me know. Like I said, during the live sesh, we'll go over the evens. Okay? So just make sure you go through these. Take the time to sit down, go through them, see if you're okay. The only thing that matters is that you're okay. Okay? All right. If you need me, let me know. That's the end of part 2.